What I'll be discussing for this session is a bit more of an in-depth technical discussion on what artificial intelligence and machine learning is from a high-level perspective. Okay. Now, just to give credit where credit is due here, so I'll be the one to spearheading or facilitating this AIMM and ML, but majority of the courses that or majority of the content that I have created there has been restructured from an existing course that we have already in Asia Open Run. This is course 416, intended for artificial intelligence and machine learning. The concept of AI is not just intended for the field of computer science, right? It continues to grow and it expands. No, it grows into healthcare, it grows into education, industry, logistics, no, and arguably so also in telecommunications and in the internet in general. No, now having said that, before I can even begin my technical talk right now, no, I'll just have a bit of an icebreaker here. So having said that, because of the different use cases that we have right now with AI, no, I've come to that conclusion wherein, especially for us, we have a lot of perceptions on what AI really is, right? So we know now that um, we have been seeing a lot of use cases, a lot of these talks about these different platforms, right? About ChatGPT by OpenAI. We also have Gemini in Google. Heck, even Microsoft also has their own versions, and even Amazon have their own versions of quote unquote AI, artificial intelligence. No? So having said that, no, so we see or we are currently in that phase of glamorizing what artificial intelligence is, right? We see this big new technology. It's the next big thing, in fact, wherein it is a technology that allows us to well, as a human society, improve on what we already have right now, right? I mean, the reason why we are even having these new technologies in place is because we want these technologies to serve as a means of innovation for us to improve the overall well-being of the human society as a whole. Well, not just in us, but even in our environments, right? But again, that concept of having this utopic idea of what AI is, it also comes with its own fears, right? I mean, we have our own perceptions on where are we heading with AI in the first place. Yes, we have already these tools in place. We have machine learning, we have deep learning, we have neural networks, we have generative AI. We also have tools that we use for research for wherein it is already AI based, right? But at the back of our minds, no, there is still that underlying fear on when do we take things too far? Why are we even being reserved on using AI in the first place? No, so are we already in that verge of going towards the Terminator, or even in worst cases? Are we even heading already towards that? Oh, I don't know. That world wherein we would be having, or we are already living in a simulated environment such as the Matrix, right? So are we already there in that verge? No, I'm sorry to break your bubble, but currently, how we see artificial intelligence and machine learning as of the moment, no, especially for those of us who are in already aware of it, and even for you guys who are already attending this session right now, if we're going to see the maturity of artificial intelligence as a whole, no, we're still not yet there. We are not yet where we hope we don't go into that future wherein artificial intelligence would completely overturn human society as a whole. I mean, hopefully, no. But again, the maturity of the technology in itself is not yet there. In fact, after my discussion right now, I hope that when one of the key takeaways that I intend to give to you is that I want you guys to eventually change your perception on what AI and ML is. It is not really that, although it has its own promises, it has its own ideals, its own features and capabilities, no? At the back of it all, it's not It's just actually a series of um, mathematical equations and models. No? And yes, it might be technical at first, but eventually in time, it would become simplified such that almost anybody and everybody would be able to use AI. And having said that, I believe some of you are already using AI right now, right? So how people see artificial intelligence nowadays is that it's not just, it's not really used for scientific or innovative purposes. Heck, some of us just use it for the sake of it, just to say that, hey, I've been using this generative AI to create outwardly and even obscure pieces of art, such as an app that I just downloaded from Google Play or even from the App Store, right? So, having said that, I hope now I'm now trying to change your perception already on what AI and ML is. So you might be wondering also that Pratik and I also mentioned AI and ML to be two completely different topics. It's because they are related, but they are somewhat different. Okay. Now, the topic that I'll be discussing right now would focus more on the fundamentals. Okay, don't worry, because even though AI and ML, if you go into the deep dive of it, is actually a series of understanding computer science. It's actually an amalgamation of statistics, programming, computer science, computer engineering, electronics engineering. um, it really focuses more on an amalgamation of all of these different fields, no? And don't worry, because although I'll be discussing a bit of technical terms here, we won't be dealing much on the programming side of it. There is, of course, an object or a field of programming that is intended for data science. We're just going to be tipping or having an overall discussion or conversation on what AI and ML is, right? We'll also be discussing here the different use cases of AI and machine learning, specifically the mathematical aspect of it. And finally, and more importantly, discuss the challenges and limitations that AI and ML is currently facing, especially on its available use cases. Okay? Now, having said that, what is artificial intelligence? Now, as what Pratik has also discussed this morning, no, it is actually an imitation of human behavior, right? If we're going to look at it from a broader perspective, this is a vastly broad field of computer science concerned with creating intelligent machines capable of performing tasks typically requiring human intelligence. So this is where the if you're going to break down the term artificial intelligence, it refers to the artificial part wherein it is in relation to not being human. Okay? However, there is no specific definition of AI, as there are several definitions of it based on who you want to ask to. Some of the resources that I was able to gather, one resource mentioned that it is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. Take note there of the portion intelligent beings. So meaning that we're not just limiting this to be within the human perspective also. So this is one definition. Some artificial intelligence systems can even be used to mimic, say, example, the movement of animals, right? I mean, if you're going to look at Nat Geo, for instance, there are already robotic simulations of sea jellyfish or other marine life that is capable of mimicking their movements, and those can even be considered as AI. Another definition of AI is that it is the simulation of human intelligence processes by machines. So notice that there is really no key definition on what AI is, at least from what I was able to gather. The point here is that artificial intelligence as a whole, it means you're trying to mimic something that is human or non-human or something that is biological using technological means. Okay? So again, we're not just limiting AI to be human intelligence, but most of the times that we have right now are implemented or mostly human-based intelligence. Okay? Now, what are the different aspects of AI? Again, AI has its different benefits, no, in place already. This is the reason why we are even um, uh, pushing or even having a lot of these use cases already at play. I was able to mention, or I was able to highlight here four. So first one, problem solving and decision making. AI systems can analyze information, identify patterns, and make their decisions based on their understanding of the world or whatever data that you give to your AI models. Another one is the ability to learn and adapt. Okay? This applies more on the machine learning aspect of artificial intelligence. Okay? AI systems can learn from data and experience, allowing them to improve their performance over time and adapt to new situations. This is also where an aspect of human behavior would come in, wherein, well, let's face it, all of us have already had bad experiences, right, before. And from there, we either choose to grow out of it, and AI is able to mimic such behavior as well in the form of data. Another aspect of it is imitating perceived human intelligence. Okay, so notice to here that I mentioned also the term perceived. This is because us as human beings are able to perceive what the AI system is capable of performing. While not achieving true human level intelligence, AI systems can exhibit some human like capabilities such as recognizing objects, understanding natural language, and generating creative context. This is where most majority of the people would have an understanding of what AI is, right? So if they immediately see a robot, an android, okay, the first thing that comes into mind is artificial intelligence, right? This is because although robotics is just one aspect of AI, it is not the end all be all. Okay? It's not robotics is just one aspect of artificial intelligence. Okay? It's actually more of concerning mimicking or mimicking out the movements and behaviors of what a human can do in the physical sense, meaning what we can see, what we can perceive. Okay? Then finally, through imitating human intelligence, of course, there is also the concept of environment interaction. AI systems can perceive their surroundings through sensors and interact with the environments through the form or through actuators. Okay? This allows them to gather information, manipulate objects, and navigate the physical world. So you'll notice that the third and fourth item are actually somewhat interrelated with each other, because we need, or AI systems, for them to be able to process data, they need the means of gathering data. Similar to how us human beings and also other living organisms are, right? For them to interact with the world, they need the means to receive information coming from their environment, right? This is where our senses would come in. AI would also have their own equivalent form of it, such as the likes of computer vision, speakers, sensors, among others. But again, we're not just limiting it through robotics, right? AI systems can also include input data, okay? And the quote unquote sensors that would come in through these models can come in the form of variables. So see how diverse and broad the concept of AI is. We're not just limiting it through the field of robotics. We're not just limiting it to say chat GPT, wherein the input would be coming as text prompts. It can even be as simple as creating a model, and that model can just accept a simple variable. That's it. Okay. Some might even argue that a simplified model can be, is it already fully AI? Well, we can say that it is partially AI or a use case of AI. Later on, I'll be discussing also the different subsets of AI. No? Now, um, you might be wondering, despite the boom that we have, I mean, when is the conversation of AI already gaining popularity? Some of you may have noticed that it has gained popularity sometime at around just this year, right? Just a few years ago, 2020, no, 2019, 2020, no, despite the challenges of what the pandemic has brought to us. And heck, it might have even be the reason why we immediately had this boom of AI by the common mass, no, there has been an upsurge of use cases available for it, right? But it might come as a surprise for you that AI didn't come during the early 2020s. In fact, it spans as early as the 1950s. So remember, so we have already come a long way. No? So this is actually a chart that I was able to gather or get from one of the websites. No? So you'll notice this is a trend. No? The lower, the x-axis here would notice here, of course, the typical timeline that you would have in the decades. No? The number of computations or calculations no, can be seen on the vertical. And you'll notice that here in this trend, we are already in the discussions of artificial intelligence as early as the 1950s. So meaning that despite the boom of AI during the early 2000s, no, the science has been around since the early 1950s. And heck, there are even some resources that will even indicate that it can even go back as early as 1940s, back when the first concepts of electronics were even being developed. Right? So we've come a long way, in fact, no? But again, just because it is popular right now doesn't mean that it was developed recently. It has already been in the works as early as the early 1950s, no? And it is only being around. So there are also related studies on it on why this trend is the current norm nowadays. Perhaps, again, one of the factors that may have contributed to it would be the pandemic because of the certain limitations that we have during the quarantine days, no? Companies, groups, and organizations needed a way to make their services more available to others, no? Without having to have physical interaction, right? So we can argue that actually that's one of the use cases that we have, right? Now, I mentioned a while ago that artificial intelligence is a broad science. No? AI as a science covers more than one field of computer science. This is also where, if you're coming from the academe perspective, no, you would see a lot of universities and colleges nowadays that are already offering their specializations, not just in artificial intelligence, but some of them can go even as niche as data science and engineering as well. Okay, some of them are also offering mechatronics. Some of them are also offering already robotics. Although if we're coming from the perspective of the Philippines, we are a bit relatively behind, no? But again, we are already getting there, right? But again, the concept of artificial intelligence can even is not just compartmentalized in one science. In fact, it covers several sciences and even some that are even philosophical in nature, right? So I say here also philosophical disciplines because definitely there are some questions that need to be asked about if something is machine in nature and produces an answer that mimics human, can we say that this machine is also sentient? So that's one question, right? So this is not really much of a technical question, but more of like a philosophical one, right? So having said that, AI in itself covers a lot of topics. In fact, the one that I'm showing here right now is just a sample Venn diagram of what AI can cover in the technical perspective, meaning that here in AI, you have aspects of biometrics, you have aspects of computer vision, sensors. Machine learning is one huge subset or one huge chunk inside of AI, but also not covered here is natural language processing, NLP, machine learning, deep learning, neural networks. Okay, there's even the ethics and the philosophies of artificial intelligence when it comes to how AI systems are perceived to be quote unquote sentient. Okay, so there are a lot, okay, of different subsets and fields for AI. Now, practically speaking, no, when people think of AI today, however, they almost always mean machine learning, okay, or the study of AI meant to train a machine to learn a desired behavior. Okay, So this is also what Pratik has also mentioned in the first session. Now, having said that, no, AI, if we're now going to have its relationship with machine learning, we can first say that AI is a broad field of computer science. Okay, so we've already established this. AI mostly concerns about creating systems and models that mimic intelligence, okay, biological intelligence, human intelligence. One subset of AI is machine learning. This is a subfield of AI focused in developing algorithms that can learn data and improve their performance on specific tasks without explicit programming. And when mentioned here, explicit programming, you don't necessarily need to have several, if you for my programmer folks out there, you don't necessarily have to create several else if statements or for loop statements just for the program to issue out a certain result. All you have to do is to create a model, and that model will then be fed with data, and based from the data that you've given it, okay, produce an output. Sometimes it might be out. I mean, it might not be the expected output, but an output nonetheless. Okay. Now, if you're going to put this same analogy to humans or to biological life forms, no, this is also where the concept of experience would be coming in, right? Wherein you learn from past experiences, you learn from past data, existing data at that, no, and from there produce an output or produce a result, no? So or a reaction in our case. Okay. Now, Pratik has also mentioned the concept of deep learning. Well, deep learning is actually a subfield in machine learning. So you'll notice how different layers are already. No? Now, in deep learning, this is a subfield of machine learning inspired by the structure of the human brain. Okay. If we're going to look at it from a logical perspective. But this is an approach to machine learning. It utilizes what's called artificial neural networks with multiple layers to process complex data and learn intricate patterns. Later on, I'll just be giving to you out what is deep learning is and how deep learning is being done. Now, we won't be dealing much on the programming aspect of it, just the high-level concept of it, okay? Now, machine learning, because it is a subset of AI, you have two techniques. Okay, so remember in the previous slide, the keyword of machine learning is that you learn from data. The question here is now, how do you learn from data? There are two techniques available right now. There is what's called supervised, okay, and of course, unsupervised. Now, supervised can be further broken down into two different techniques called regression and classification. Whereas in unsupervised, some textbooks or sources would include here clustering as a part of a type of machine learning technique, unsupervised machine learning technique. Some of them would also incorporate the association rule learning. Okay, so later on, I'll be discussing briefly also here what do we mean by regression, classification, clustering, and ARL. Okay, so some of you, I believe we have attendees here who are in the education field, no? You might also be familiar on these terms, specifically in your statistics. It's because they are. They are related to your statistics, no? And that is also why if you really sat down and understood what really ML is, no, it is just a different approach on how you perform statistics, right? So having said that, I'll first now discuss what is supervised machine learning. Now, supervised ML builds a model that creates predictions based on the evidence in the presence of uncertainty. Okay? However, despite that uncertainty, you have past data to refer to. Okay? Supervised learning, its algorithm, takes a known set of input data and known responses to the data and trains a model to generate reasonable predictions for the response to new data. If we're going to put that in a real life perspective, no, suppose say I learned that this picture is a cow. Okay. And then immediately I know now that this picture is a cow. I see another picture of a four-legged animal. And then I was taught in school that this is the picture of a horse, right? A cow and a horse both has four legs. Okay, so let's put it at that for now. Okay. Um, if you now present to me another four-legged creature, and I know that it has the characteristics of what a cow should have or what a horse should have, I can immediately say that this is a cow or a horse, right? So put that in a scientific perspective, that is what supervised learning is. Okay? You have input raw data. These data is labeled, meaning that you know its result, you know its outcome, and these data sets are fed into the model itself. Okay, machine learning is about creating models, in fact. Okay? Now, based from the past or input raw data that you have, i.e., the experience that you fed into your model, if you now give your model a new training or a new set of data, it would then refer to the past data in order to produce a result. Okay, so this is where the concept of supervised would come in, wherein the portion of supervision would be coming not just from the training data set, but also the desired output. Okay, now we have two classifications of machine learning. There is what's called regression and classification. Now, based on the type of data that you have and what you want to get from that data, you can choose either one. Okay? If, say, your data is continuous, meaning that, for example, in real life scenarios, no, majority of data analysts that we have right now, often, well, specifically those that monitor the stock market, they have past data to refer to, and this data is changes in time. Okay, this is what's called also continuous values, wherein you have a specific value and it has also a specific result. Okay, it can even be a date. A date or can also have another variable, and then this variable has a specific result. If you feed it with another value, it would produce a result that is somewhat similar to the past data that you have based on a given date. This is what regression is. Okay, this is a type of supervised learning that is used to predict continuous values such as house prices, stock prices, customer churn rate. Anything that is continuous in value or in nature. That is why regression algorithms learn a function that maps from the input features to the output value. Okay. Take note, however, that in regression, it doesn't always imply that the output would produce a straight line as what is being shown here, right? So in your basic math or in your basic algebra, we're taught here that it's as if does everybody or does it have to be like a straight curve or does it have to be always a linear curve? No. Depending also on the algorithm that you feed your regression data model, it can be a trend, it can be a waveform, it can be sinusoidal, it can even be trapezoidal. So it depends really on what you want. The point here is that you have an expected output. So that's why if you feed it with historical data, you now know, or the model would now know, what is the intended output. Okay, so that's regression. If you have continuous values, you can use regression. Okay. What if, say, I have values and I want to, say, sort them out? This is where classification would come in. Classification is the process of finding or discovering a model or function that helps in separating data into multiple categorical classes. In other words, if regression is normally used for continuous values, classification is normally used for discrete values. When we say discrete values, no, sorry guys, in your statistics here again, it refers to values that are, say, um, discrete or compartmentalized or just a single value. Okay, an example of here would be, suppose I have a data set that consists of colors, say maroon, cyan, vermilion, viridian, saffron, and you know these colors to be different subsets of the primary colors such as red, blue, green, and yellow. You can use classification to say into your model that, okay, if I know that cyan is a shade of blue, and I know that vermilion is a shade of yellow or orange, no? If I feed it with color named saffron, what will it tell me, right? What kind of color will saffron be? Is it the shade of blue, a shade of red, a shade of green, a shade of yellow? Okay? The answer there is, of course, a yellow, but still, the concept here is that you're trying to classify data based on the existing data that you have. Okay? That's why it's called classification. Okay? So this is supervised machine learning. Okay? So you'll notice that you have existing data, you feed it into your model, you use that previous data in order to have an intended result. Okay? Now, there is another aspect or there is another technique for machine learning which is called unsupervised learning. It's also what the name implies, no? Unsupervised learning is the training of a machine model using information that is neither classified nor labeled, and allowing the algorithm to act on that information without guidance. In other words, if we're going to look at it from the entire machine learning development process, you're just going to create the model and then that's it. Okay? Unlike supervised learning, no teacher or trainer or supervisor is provided. That means no training will be given to the machine. You give full credence to the machine in order to make sense of what data it has in store. Okay, therefore, the machine is restricted to find the hidden structure in unlabeled data by itself. Okay, now, if we're going to look at it from, again, from my example a while ago about four-legged creatures, I only have here, say, I'm only fed, okay, these are four-legged creatures. Make sense of them. Okay, so the process is, although a bit simplified in our sense because we don't need to train any data of it, no? We allow now the model to make understanding or to gain insight on the data that we have fed to it. Notice also that you're not feeding it with historical data, okay? You are giving full credence to the model to make sense of what the data is. Because I have here four-legged creatures, okay, the model would now understand, okay, so four-legged creatures, but I noticed that some of these creatures have spots, some of them have fur, some of them are bigger than the others. Perhaps I can group them together to make sense of what the data really is, right? So that is unsupervised learning. And you'll notice that from that mindset alone, or from that process alone, wherein you are already trying to make sense of the data by grouping similar characteristics of them together, this is where now the different techniques of unsupervised learning would come in. One of them, as I've already mentioned, is in fact an example called clustering. Okay? It's similar to classification, but unlike in your classification, wherein you give the model already the classifications that it should refer to, in clustering, you allow the model to make sense of what the data is just by looking at the data points that it has as of the moment. Okay, so clustering algorithms work by iteratively moving data points closer to the cluster centers and farther away from data points in other clusters. Okay, so meaning that in the clustering process, no, what the algorithm or what the model would do is that it would choose a random point, okay, Of course, this is data set. So again, sorry about your statistics here. It would select random points across all of the data sets here and try to make sense. So these data points would then be reserved as your reference points. And from there, the model would then either group together similar data points that share the same characteristics as those select data points. If some of them are more common together, then some clusters can even be merged together. Okay. Again, you're giving the model here the leverage on how it makes sense of the data. That is also why in clustering, ideally, no, when you see now your data set, when you try to visualize it in the form of a graph, as what I'm showing to you here, ideally you should be able to see here some clumps or groups, no, like it should be like in circular form. But again, in real life scenarios, it's not always this case. Sometimes they can be grouped together as one huge blobs, no, such as the one shown here in the graph below. And you can immediately see here some data points that are somewhat in technical terms, these are what you would call your outliers, no? But these are your somewhat rogue data points, right? But still, you would see here that you have some commonalities. Now, a bit of a caveat about clustering is that just because you give your model the liberty to make sense of the data, it doesn't mean that you as the programmer or the data scientist is no longer hands-on. In fact, it is still your role to set a specific threshold that the model would use in order to make sense of what the data is. So in my example here, no, suppose here in the upper graph, I've set a threshold of the clustering model to be 3. So meaning that the model would then create or choose 3 random points, and from there, try to group together your data sets based on those 3 data points. Okay, so it's still your role as the developer and as the creator of that model, no, to set a certain threshold, right? It's in the matter of no longer spoon feeding the model on what to produce for that given outcome. Okay? So that is clustering. Now, the other one is what's called association rule learning. Okay? Association rule learning. Now, there are some textbooks and some references that refer to only clustering as a technique or the sole technique for unsupervised machine learning, but there are actually some also. So one example of this is the association rule learning. Okay? Now, ARL, this is a type of unsupervised learning that checks for the dependency of one data item on the other data item. In other words, you're trying to gain insight on the association. If you have a given data point, is there an associated data point to this one? Okay, so that it can be more profitable. So normally this is used for correlation. In other words, if this data point exists, are other data points also existing once this one is also existing? I hope I make sense. No? It tries to find some interesting relations or associations among the variables of data sets. It is based on different rules to discover the interesting relations between variables in the database. Now, just to give you an example here, suppose I create a model that is capable of grouping together or understanding a specific data point. Okay, so in my example here, just a simplified view, no? Suppose the model is able to create 5 clusters. Okay. Now, based on those 5 clusters, it is able to find out that all 5 of them, well, 3 of 4 of them, sorry, have milk as part of their data set. So this is more of like attributed to marketing or even to sales. Okay. So what do you notice at customer 1, 2, and 3? All of them have milk. Is there an existing data across all of the 3 who has milk, wherein other data sets are also existing? So in customer 1, milk was purchased with bread and butter. Customer 2, milk is purchased with cereal, bread and butter. Customer 3 is able to purchase milk, bread and butter. Customer 4 just purchased sugar and eggs. So just looking at that, we are now able to see here or gain some insight. Just by purchasing milk, is it also associated that customers are also able to buy, or whenever customers try to buy milk, can it also be associated that they would also likely purchase bread and butter as well? So this is an example of association rule learning. You're trying to get associations based on the existing data that you have. If A is existing, how does it correlate to B? That is ALR or ARL rather. Okay? And again, similar to clustering, you set a certain threshold. No? Again, no, you may have also noticed that although some of the terminologies here are, ARL is somewhat similar to what we would normally do for, say, in statistics, say in chi-square testing or even ANOVA, wherein we are trying to find the correlation of one thing to the other. Okay? So it's because it is, right? Machine learning nowadays, in terms of its practicality use, is normally used as another means for us to do computations and calculations, no, as quickly and as efficient as possible. Okay? So, again, no, in summary, no, machine learning, again, regardless of whether it is supervised or unsupervised, no, it still points out that it primarily deals with feeding it with data, no, the model that you have created, and then expecting a result from the model based on the data that you have fed it, whether it is training data or the actual data itself. Okay. Now, I can go through a lot of algorithms on the different types of, say, regression, classification, clustering, and ARL algorithms available right now. In fact, there is what's called linear regression. There is also called logical classification, clustering by means of k-means, among others. No, but again, the concept here is really much on understanding these different types so that you'll know when you have data, how can you now make sense of what your data can be. That is actually how useful machine learning it is nowadays. No? How can you make sense of the data that you have right now? Okay, so having said that, no, I'll now take one step deeper into the layers that we have already. So we have already discussed what AI is. We have also discussed what machine learning is. We now briefly discuss what is deep learning. Okay, some of deep learning in itself as a science is already complex on its own, right? But we'll try to simplify it for now. Okay. Again, deep learning is a subset of machine learning. Okay. It uses also artificial intelligence. It is a use case of artificial intelligence. Okay. However, what makes deep learning unique is that you create models which are called neural networks. So you may have wondered, no, neural networks. It sounds somewhat similar already to your biology. Okay, so these networks are inspired, in fact, by the human brain and can be used for things such as recognizing images, understanding speech, and processing language. Now, there is a limitation on the 4 classifications that I have shown to you a while ago. These ones. Okay. Some simple models that we have right now or techniques, no, on how we can process data primarily deals with data that is I don't want to say text-based, but simple data. Let's put it at that. Okay? Simple data. Wherein you have a value and it corresponds to that is already the data itself, the value. Okay, but in the real life scenarios, we're not just dealing with text-based values, right? Some of us deal with images, some of us deal with sound. Okay, vision or image can actually be translated into binary. Okay, but it is one long continuous data set. Okay, something that cannot be immediately processed if you're going to create or type a script for it on its own. Okay. So with the complexity of data comes also the complexity of how you process the data. This is where the concept of machine learning, or sorry, of deep learning would come in. Okay. Now, in terms of its use case, although it is not limited to that, most of the deep learning applications that we have nowadays are primarily used for generating images, recognizing images, okay, understanding speech. In other words, in fact, I believe we are already using one right now, wherein as I talk right now, there is an AI model already running at the background, okay, carefully transcribing each of the words that I am saying as of the moment. So it is able to understand my speech, it is able to understand my words, and from there properly translate it into text. Okay, but my text or my voice doesn't just stop at one go. It doesn't stop there, right? It continues to flow at least until the session has ended. So how can a model be able to process continuous amounts of data, okay, without completely breaking or without the programmer itself wrecking their brain into identifying the best possible model to create for that specific application? Deep learning is now your answer. Okay? Deep learning needs lots of labeled data and powerful computers to work well, but it can achieve very good results in terms of its application. Now, I mentioned in deep learning, it uses what's called artificial neural networks, or more specifically, artificial neurons, right? So we are already dealing here with a bit of biology, but please bear with me, okay? So a bit of biology 101 is in order first. So don't worry, this would make sense later, okay? So for those who have taken their biology, you may have also known what this is, right? So this is a neuron. For those who are not in the medical science field, so the neuron, this is the cell normally in your, or this is the cell in your brain. Okay. Now, a bit of a disclaimer here. I am an engineer. I am not a medical professional myself, but this is also the best analogy that I can look into. Now, a neuron consists of, in a high level, no, three basic parts. You have what's called the dendrites. Okay, I hope I'm also understanding. I'm also pronouncing that right now. We have the dendrites. These are the fibers that, if you're going to look at it on a functional perspective, this is used to receive input signals from connecting neurons, okay, probably from their actions, okay, in order to receive data, okay, or the signals themselves, the brain signals, okay. Now, the dendrites are then connected to the main body of your neuron, okay, which I believe this is called the soma. Okay, so the soma, this is the main body itself, which consists of the nucleus. And in a way, you can say that the nucleus and the soma, this is where the signal, the brain signal is triggered or processed. Okay, then finally, after it has been triggered, no, it goes out into what's called axons and axon terminals. Okay, so the axons are then used to communicate it towards other connecting neurons, okay, or to another gland, such as the pituitary gland. Okay, so again, I'm sorry, I'm not a medical professional, but you'll notice now that a neuron consists of three basic parts: a dendrite, the soma, and the axon. Okay, in an artificial neural network, it is actually modeled to look something like this. It would now look like your dendrites. This would serve as your input layers. Okay, each of the input layers, these can be considered to be your variables. Okay, notice that you're not just limited to four. It depends also on the type of model that you would be creating. But the point here is that you have input signals or input layers. Okay, each of the layers are then assigned with a random weight. And from there, no, whatever value that you feed into an input layer is fed into two parts, okay, which is called the summing function and the activation function. Okay, this is already coming from the concept of mathematics. Okay, so the function or the role of the summing function is, as the term itself, it sums up all of the different parts of your input layer. Okay, and then the activation function itself, this is where a threshold is set in order to identify if this input layer is considered valid or not. if I were to simplify it. So the summing and the activation function, this corresponds to the soma into the biological neuron. And finally, the axons that would be then connected, or in your artificial neuron, this would be now your output layer, okay, which is then fed into another layer, okay, and or into the final output. So notice now that how an artificial neuron is structured, it is somewhat similar to a biological neuron. Okay, now put these cascade an artificial neuron into several layers. That is where deep learning would come in, or your neural network. Okay, now a neural network is usually described as having different layers. Okay, the first layer is what's called the input layer. It picks up the input signals and passes them to the next layer. Normally, the input layer is also where the image, the speech, the text is fed, and then it is fed into what's called hidden layers. The reason why they are called hidden layers is because you as the developer don't really need to mind yourself on what is going on inside the layers. Okay, so it does all kinds of features, calculations, extractions, interpolations. Okay, again, they are called hidden. It's because what you are just intended to is the output result, which is found in the output layer. Okay, hidden layers can also consist of several layers at the same time. It's not just one. In fact, you can have as much layers as needed. Okay, so now it begs the question, how does now our neural network able to make sense of your data? So by the way, the images that I have gotten here, I got this one from Simply Learn. So you can look at it into their website as well if you want to understand it better, no? Okay, so just a high level overview on how neural networks work. Okay, suppose you have an image, say the image or the facade of a car. And this car is, or the objective is for you to identify its plate number. Normally, this is used for image detection or image processing. Okay, now, the typical image of a car would consist, of course, because this is a digital image, it would consist of several pixels. Okay, each of the pixels are then fed into your input layers. Then weights are then assigned to each of those layers randomly, and then they are eventually fed into the hidden layers. Now, how they are labeled here, no, it is arbitrary, but for this diagram, what it would do is that the first layer, the first number in your neuron would correspond to the layer, and then the second number would correspond to that specific neuron for that given layer. So here we have W11, which stands for the first neuron in your first layer, and then the second neuron, and so on and so forth. Okay, now you as the developer or the programmer don't necessarily need to take, or don't necessarily need to put into consideration the calculations being done within the neural network. All you have to do is to configure the model, okay, the neural network model, what you intend to do, and set thresholds to it. Okay, so it is somewhat similar to also your unsupervised machine learning. Okay, now as layers, or as a specific neuron processes the data, after it has go through or passed through what's called the activation function, it is then fed to the next layer. Okay, and then as the signal flows within the hidden layers, the calculated weighted sum of the inputs is calculated, and then it is fed to the activation function in each layer to decide which nodes to fire. Okay, some of these nodes are in fact activated, some of them are not, based on, say, the input that is being fed into the previous layer. Okay, now feature extraction can also be done within the given hidden layer. So in our case, if say the objective is to extract the plate number of that given car image, then all we have to do is within the layers tell it that, hey, this portion or this segment of your pixels is the point of interest. This is where we want to get the picture of the car plate. Okay? Now, how does now the neural network learn from the image itself, right? So you may have noticed that in the diagram, although it is being fed from left to right, no, once it reaches a specific layer, it is then fed back. Okay, this is because also, by the way, this is called what's called back propagation. If there are errors being encountered while the images or the pixels are being processed into, the model can learn from them. Okay, so this is again the concept now of supervised learning. Error in the output is backpropagated through the network and weights are adjusted to minimize the error rate. So this is calculated by a cost function. So this is another concept. No? So every time a specific data point or data set from a node is passed on to the next, no, it is also calculated with a cost function. If I were to put that in simple terms, a cost function, this is a function that is triggered based on the number of iterations a pixel has already gone through or a data set has already gone through. Okay, so it's a bit complex in fact, but the point here is that in terms of its structure, notice how a neural network is now different from supervised and unsupervised learning, the one that I have provided you before. Now, are we saying that we cannot implement regression, classification, clustering, and ARL using neural networks? We can. Okay, in fact, some neural networks are based on, we can implement regression in neural networks. We can implement classification in neural networks, right? In imaging, in specifically in image detection, normally what we use is what's called convolutional neural networks. Okay. In engineering terms, convolution, this is where you set a certain threshold and then that threshold goes through all of the different pixels into your image. No. So there's a bit of a nuance to it here. But the point here is that neural networks is just an approach on how you can implement machine learning. There are a lot, in fact. Okay, and having said that, no, what's the key point here, despite all of the discussions that I have given you into? The important thing to consider in machine learning is that there is no one-size-fits-all algorithm. You really need to understand your data first before you can process the data. Okay? If, say, you have stock market data, is it really valid for us to classify the data points? Okay, it would depend on the requirement, but most of the time, the reason why you are getting stock data is because you want to predict what would be the next value based on the past values. So for example, I have, say, the stock market trend of Jollibee, right? And I want to understand or I want to decide on whether I should invest in Jollibee for this year. So what do I do? Of course, I look into its historical records. I look into its past records and see that, okay, so Jollibee had significant revenue returns at around 2019, also 2020, but they had a bit of a dip in 2021, but they rebounds back in 2022. So you'll notice that you are already referring into regression-based data. So you use regression machine learning. So that based on the historical data of Jollibee, you can make sense now. Okay, if I invest this amount at this month, what would be my forecasted or projected return for this month? So that is one practical use. Okay, so another example here. Suppose, say, I have, or as a researcher, I was able to gather, I conducted a survey, and this survey is about, say, the significance of AI in social media. And I want to gain insight on how many of my respondents are using AI in their platforms, okay? And can I gain some insight on what specific platform of AI are they using? So based on that question alone, you can already understand where I'm coming from. I'm now trying to classify or understand the data set that I have, my respondents, and from there gain insight. Is there a specific pattern or a specific trend on the number of my respondents that would veer towards using ChatGPT or using a generative AI to create their images? Or do they, some of them use AI in enhancing their photos? So from there, the concept of classification would come in, or even in clustering if you want to. Okay, the point here is that you really need to make sense of what your data is before you can tip your toes into what algorithm you can look into. So I was able to find here a good flow chart, no, and in fact there are some resources that you can look into here, no. There is actually a certain, or there are flow charts available in the internet right now that you can use. You can use this one. In fact, I also got this one online, wherein you now try to ask yourself, how valid is my data? In what sense do I want to make my data from? Okay, so if my objective, say, if I want to create an application that would accept user input data and but that user input data would be based on, say, the news. I want that that application be able to give me results coming from different news websites. But unlike the others, I want to have a chat GPT-esque UI wherein it would create, or it would ask for prompts instead of predefined options. So from there, another concept would come in, natural language processing. Okay, wherein you have to understand, or you need to understand how you get inputs from your end users and process them based on a specific language, because locality also is considered here, and make sense of what the user has entered based on their text. Okay. So because machine learning depends on data, so you may have also noticed now that there is a lot of data involved in machine learning and artificial intelligence as a whole. This is where now the concept of data science and engineering would come in, right? Because we need to make sure that the type of data that we feed our model into is correct and complete before it is processed by the model itself. That is why data pre-processing, no, and preparation is no exemption for machine learning. You have to go through several steps first before you can actually create the model that you want your model to process into. That's why also part of the life cycle of a model also involves data preparation, data modeling, and heck, there is even optimization involved. Okay, there is what's called also a behavior called underfitting and overfitting a model based on a certain data set. How accurate do you want your model to produce based on the result? Okay, so optimization would also be involved here. Before you can say that, okay, so my model is already robust enough to be able to handle such data. Okay, so now I have mentioned the different benefits, advantages, and features of machine learning and AI in general. You know, I was able to discuss to you the nuances on how you can create your own machine learning model, the different types and its classifications. No, but again, no, the science in itself, the technology in itself as a whole, it's still arguably not advanced enough for us to say that it can already replace human intervention or human actions. Okay. So what are the limitations of machine learning and AI in general? Number one, this is the number one item, ethics. Okay. Although majority of models and AI platforms that we have right now are already streamlined enough, optimized enough, there is still the question of ethics. AI algorithms depend on data that you feed it into. That is why certain biases can also be given or present when the data is fed into the models themselves. I mean, if you are up to news nowadays, no, I mean, I think it was just yesterday, I watched it in CNN, Google Gemini. If you're familiar with the Gemini prompt, of Google. This is their competitor to ChatGPT. They have, I believe, temporarily disabled their image generation feature. This is because of I believe, a certain issue about racism. I think this one was featured in CNN just yesterday. No, I wasn't able to include it here in this slide. No, but I think one of the posts there was one user tried to enter the prompt, generate an image of a pope for me. And then what Gemini produced are pictures of not just a pope for the Roman Catholic, but also a pope for, say, other religions. And by that, I mean they are not male popes. Some of them are colored, meaning they are skin of color. Okay, and just by that image alone, it already spanned a lot of conversations about um, uh, I don't want to say racism, but yeah, it's more of like on already veering on that point. Okay, there is also the concept of some AI platforms having a bit of an undertone towards, say, terrorism or even anti-Semitism. Okay, that is also the reason why some companies that we have nowadays are really either disabling or fine-tuning their AI platforms to be more ethically acceptable. But again, the bias is there. Okay, so AI systems can also raise not just on biases in terms of ethical standards, but also data privacy and security. No, when AI gained popularity in the early 2020s, no, there has also been an upsurge and uproar by the art community, wherein some platforms of art galleries, in a way, no, having their websites being exposed to AI companies for profit without the artist's consent. Meaning that some of the generative, I'm sorry, but here is really the real news that you have, no? But some of the image generating AI apps that you are using right now might be even using art, okay, without the artist's consent. For example, here, I believe there is an app wherein you can generate a picture or a portrait of yourself using the Ghibli art form. Or the other one would be, say, you upload there a picture of your portrait, and then it would show to you the early 2020s yearbook photo of yourself. Unrealistic, but still, no? So it begs there the question, where did the AI get the data in order to regenerate this image? So that is one huge question mark there. Okay. Another problem or limitation, deterministic problems. AI and machine learning excel at finding patterns, right? And making predictions. However, logical reasoning and common sense needs also to be considered, especially when dealing with new situations. Okay. In the scientific perspective, this is where the concept of underfitting and overfitting would come in, wherein if your model is too strict in receiving data, it might consider the data to be too rough around the edges, so to speak. Okay, but if it is too lenient, it might overpass or miss some data that is actually relevant. Okay. Another one is correctness and completeness of data. The performance of AI models heavily rely on the quality of data they are trained into. That is why in my previous slide a while ago, no, you have to make sure that the data that you feed your AI model is correct and complete and concise. This is because whatever you feed the data, the AI model into can be inaccurate, incomplete, or even biased. Again, the question of ethics would come here into play. Okay, I believe some of you have also encountered this, and well, there are students here, in fact, no, some of them are using already AI platforms such as ChatGPT and Gemini, no, in order for the in order to conduct their research, their related literature review, just for an example. Okay. You can just type it, you can type in your chat GPT or in your Google AI, give me related literature for this topic, right? And then as if by magic, it would produce a list of related literature, and you can even specify what format you want it to be. Either do you want it to be in APA, in MLA, or IEEE, it's up to you. Okay, but the question here is, how accurate is the result? Have you tried to look into the related literature itself? Try to look into the title of that research paper being referred to and check if they are really valid or not. Because sometimes this is also based on personal experience, wherein it would produce a result, but when you try to cross-reference or cross-check that reference, it doesn't exist. Right? So this is also a behavior in machine learning called hallucination, wherein the machine learning model would try to literally make something out of thin air. Okay? So this is where the concept of correctness and completeness would also come in. I mean, let's face it, nowadays, the conversation of already using AI tools, especially for research and development, is already there. It's already prevalent. Heck, you can even watch YouTube channels on how you can make or on how you can use AI tools in order to make your research better, on how you can make your schoolwork better. But make sure that they are actually correct in the first place. Okay? Because that is also a limitation that we are currently facing right now. Not everything that AI produces is factually correct, if I were to simplify it. And having said that, the next one is misuse and misapplication. Okay. Unfortunately, because of the advancement, especially on generative AI, wherein we are already creating images out of thin air, the concept of deepfakes has also increased, or the number of the use cases of deepfakes have also increased. This can often lead to misinformation or even to a public outrage. Okay, some of the news, in fact, in the US, have deepfakes of former presidents and of former people of power stating something about the current news and situations that we have right now. I mean, I believe some of you have also encountered there. It was popular back then in Facebook and even in Instagram, wherein you have the pictures of our heroes from 100. You can make Apolinario Mabini sing My Milkshake Brings All the Boys in the Yard, okay, word per word. Okay, you can even make, I'm sorry here, but some of our past heroes in our bills, no, sing whatever the heck that you want. Okay, have you ever seen Manuel Rojas sing Taylor Swift? So you can already do that in AI. But my point here, not just for entertainment purposes, some of them are already using these advancements for malefic purposes. Okay, they're just creating this just for the heck of it. Okay, and then the last one is, of course, interpretability. Okay, many AI models nowadays, especially in deep learning and in neural networks, can often be complex and opaque, meaning that just by the process of neural network creation alone is already a bit of a complex process and requires a bit of a nuance, right? So meaning if you don't really know how to interpret the data produced by the model in itself, okay, you might be prone also to misinterpretation. This lack of interpretability can often, in worst-case scenarios, hinder trust and accountability. Okay, and often it can even lead to more effort just by debugging the model that you've created alone. Okay, so having said that, despite the advances of what AI and ML can have, whatever benefit that it can have to us right now in the society as a whole, it still has its own limitations. No? So just a quick recap. No, so we've discussed a lot in this topic nowadays. So again, AI. This is a field of computer science concerned with creating intelligent systems capable of mimicking human behavior or biological behavior. And similar also, regardless of it being artificial, it still requires human intelligence. Okay. AI started as early as the 1950s and gained widespread during the early 2020s. So just because it has become popular nowadays doesn't mean that it is just being developed now. Okay? It spans way back. Okay? AI covers a wide range of sciences and fields. Okay? We've discussed this. It covers computer science, electronics, computer engineering, electronics engineering, electrical engineering, medicine, and even philosophy. No? Now, focusing on machine learning, ML is a subset of AI, which focuses on creating algorithms based on data. And from there, deep learning is a subset of ML that uses, or it is an approach on how you can process data, but this approach requires artificial neural networks. Okay. And finally, despite the benefits of using AI and ML, okay, it would still also have its limitations.